Hello everyone. Today I'm going to take you through the basics of using the Astra DB Data API client for C#. We're going to go ahead and look at the basics of connecting up with the API, querying data, and even serving out some of that data with a service layer. So I should probably start by introducing the Killer Video application. Killer Video is meant to be a Netflix clone that works as a reference application to show how to use the different features of DataStax's Astra DB, and maybe even at some point the different components of watsonx data with IBM. But for now, we're just going to focus on the Astra DB components of this, and again, and how it relates to .NET C# as well. Additionally, we also have the Killer Video GitHub organization, and this has all of the repositories that are related to running Killer Video and that have gone into it. There are things out here such as, the data loaders, things with creating the data model, the React.js web front end that we have, as well as backends available in Java, C#, Go, and Python, and sometimes multiple in the same language that actually access the data in different ways. Whether it's CQL or from the collections standpoint with the data API, or from the tables standpoint with the data API. There are many ways in which you can interact with Astra DB from the application side, and we do try to cover a good smattering of those perspectives here. Real quick too, let's take a look at Astra DB here. So if I have a look at the Killer Video database that we have out here, I can say go ahead, I can click on the Data Explorer, make sure we're looking at the Killer Video key space, and if I slide down to the videos table, you can see we have things like different properties for the videos themselves. I can also open up a CQL console here. And inside the CQL console, I can do traditional, run traditional Cassandra commands like use Killer Video, and we can say describe the videos table. You can kind of see, a lot of the columns that I was just talking about. This one actually has a fair amount of indexes. You don't really need all of these indexes, but again, kind of the main one that you're going to need is this content features index, which allows for, like a cosine related ANN or approximate nearest neighbor search on the video data itself. Likewise, you can have a look at the contents of this table too. So we can do like a select star from videos, and I'll just say like limit 5. And you can see that, yep, we do get, the top 5 videos, listed out in that table right there. So, yeah, so that's the schema, that's the data model, a little bit about, some of the data that's out there. So let's move on and have a look at the code. So this is the videos class, and the idea with the videos class is that this is used to, kind of help with serialization of objects in the database or rows in the database as they come back into objects inside of your application. So it should mirror that table pretty closely. In this case, we use, attribute properties, like this column primary key, indicating that the video ID is our primary key for this table. You'll notice that we have column name here, again, designating, the column name as to how it matches up inside of Astra DB. I also have the JSON property attribute here because as we pull this data out, and show it as JSON for the RESTful services that we have, those property names will likely be different than what you have inside the database. Now, that might not always be the case, but in this case, it is. So there are ways to account for that, and using both a column name attribute and a JSON property attribute is a way to get around that. The video ID is a GUID, so we have that as well. And then, we have, all kinds of other different, properties on this as well. Now, to connect up to Astra DB, what we're doing is we're taking 3 environment variables, we're taking the Astra DB application token, we're taking the Astra DB key space, and the Astra DB API endpoint. Now, all of these properties can be found inside of your Astra DB dashboard, that I was showing you before. And the idea is that you'll instantiate these properties here as environment variables. When we go ahead and we run our project with .NET, it'll go ahead and pick those up, and this is where it pulls them in. And the idea is that we're just creating a new data API client object, and we're doing a get database with our endpoint, our token, and our key space, and then going ahead and returning that as well. Now, if we move on to the video DAL, or video data access layer, you can see that we actually do have a private variable here for our database. And of course, that's going to go ahead and pull from our Cassandra connection class that we were just looking at a little while ago. So we're going to go ahead and do that get database method, which is going to pull down the database locally. Additionally, each one of these methods allows for various CRUD operations, create, read, update, delete, on the videos table. And since this is the video DAL, we're really only dealing with the videos table here. So, here's a method, again, called save video. It's an async, so we're going ahead and, defining our table as database get table, making sure that it has a type of the video class that we just looked at before, making sure that it's tied to the videos table specifically as it's named inside of Astra DB or Cassandra. And then we're doing an insert one async of our video object. Oh, here we have one that gets called quite a bit. It's get video by ID. So essentially, we're passing this video ID GUID and using that as a filter. So, we have our filter builder here with the equals operator of, looking for that column named video ID, and also passing the value of the video ID variable. So this, of course, will also do a find one async on that filter and pull back that row into a video object here that will return. The other main significant one that I wanted to show is the get by vector. And again, this one is useful in a recommended or related videos kind of a call. So the idea is that you would click on a video, on the in the web application, and it would take that video and take its content features vector embedding. It's going to pass that vector embedding to this method, this get by vector method, and with a limit as well. I think by default our limit is related videos. I want to say it's like 5. Yeah, so we'll pass something like that. But the idea is when you run a vector search on a database, you almost always want to have a limit. And in fact, I believe Astra DB will make you have a limit, and Cassandra should do the same as well. So the idea is, again, we create our local table object here, and then we go ahead and do a table find, and we sort based on that content features column with the value of the vector that was passed in, and we enforce the limit that was also passed in. The find command will return an enumerable of type video, which we will then return back up to the service layer. The service layer you can see inside of the video controller here. This is where we kind of set up, like, hey, this is our route for like API v1 videos. We're making sure that it produces application JSON. But, you can see some of our methods here, some of the more simple ones, like this get video method. It's hosted out at the ID endpoint, where it's literally the property name ID, followed by a slash, and then followed by spot to hold the variable of the ID that you're looking for. And this is where it calls that get video by ID method that we saw on the video data access layer. And again, the idea here is that it's pulling that back from the database, and the controller layer handles interpreting what comes back from the database and then showing it or serving it out in a RESTful fashion via the endpoints here. So we also looked at the related videos endpoint and how that uses vector search to pull back related videos. So the idea here is that we have an ID, we have a requested limit. We want to make sure requested limit is some sane value. We don't want a limit of like 1,000. We don't want a limit of like -5 or anything like that. We want to make sure it's between like 0 and 20. More than 0, less than 20 is kind of about what we want. With 5 as a default here. We're first going to pull back the original video by ID. Then we're going to use that original video to pull back its content features or vector embedding, and we're going to send that out to this getByVector method. And then we have a for each down here that processes that similar videos enumerable that comes back and builds it into a response that we return back up. So that's a good example of how the controller layer works. So I'm inside of the repository cloned locally. Let me just do an ls alter. You can see, yep, this is my project directory. So let's just go ahead and do a .NET run. So this should go ahead and, yep, okay. We're now hosting out on HTTPS 7264. Now let's go ahead and open up a new window. Let's do let's check for latest videos first. So let's go ahead and we can test these endpoints with a curl command. So let's go ahead and say curl -k-x. I'm going to do a GET request, and this is HTTPS localhost. What did I say? 7264 is the port, and we're going to do API v1 videos and just latest. And it usually helps when I have 2 slashes in there. All right, so let's go ahead and run that through JQ just to maybe kind of pretty things up a little bit here. There we go. All right, so yeah, as you can see, we have some individual latest videos coming back here. Additionally, too, I can check on a specific video by using that video ID endpoint. So if I kind of backspace there and say ID /, then we paste that in. There we go. So we have some things here like the YouTube video ID. We have our 384 dimensional vector embedding. And up here, video ID, title, description. This one's about using a basic agentic workflow with DataStax Langflow. We have our YouTube endpoint. Yeah, so this is working. All right, well. All right, let's open up a new window here. And let's say CD documents. Color video. React front end. There we go. And we're going to say export Vite backend URL equals HTTPS, 2 slashes, 7264. Let's do that. And then let's do a npm run dev. There we go. Now this should be out there on localhost. Yep. Oh, 8080. And there we go. Okay. There, app, and it loaded our featured videos. So let's go ahead and let's have a look at one of these. We get our related videos back, showing that the related video endpoint is indeed working. And of course, what good would a Netflix clone be if it didn't actually work? So you can like click on this and
create a table called
see that
users.
It does indeed work. And play the video. Thanks for sticking with me thus far. You know, I hope you all enjoyed this short video on how to build in C# with the DataStax Data API for Astra DB.